In this video, we're going to talk about finding the limits of rational functions. And we have a rule for finding the limits of rational functions. Our rule says we just stick in the C, but for that rule to work, we have an additional requirement. The denominator isn't allowed to be 0. What if the denominator at C is 0? There are two options. If P of C equals anything other than 0, the limit just doesn't exist. For the first of the three possible reasons we gave for non-existence, if the denominator is going to 0 and the numerator isn't, this whole fraction is going to infinity. So the only way the limit can exist is if P of C and Q of C both equal 0, and we sum in the remnants of our college or high school algebra. If a polynomial has a root, we can factor the polynomial so that x minus that root appears. And if these are both 0, we'll have an x minus c term in the numerator. And in the denominator, that will be able to cancel. So this is the kind of thing that probably just needs an example to be made clear. Let's look at the limit as x approaches 1. We'll have x squared minus 1 in the numerator. And let's depart from the notes to make this a little more complicated. X squared plus 2x plus 3 in the denominator. This is a rational function, so we have this theorem. The very first thing we should do is just plug 1 in and see what happens. Unfortunately, what happens is that we get a division by 0 error. So that's no good. We have to try something else. What if we factored the numerator, and we factored the denominator. Let's see, the numerator was pretty straightforward. Multiply together to be -3, add to be +2. This, let's check this, x squared plus 2x minus 3. Okay, so that's correctly factored. Just like we said, this 1 was a root of the numerator and a root of the denominator. So we knew we needed to have x minus 1 terms in both places. Factor that. And now try again. We have a limit of a rational expression unless it gives us a division by 0 error. We ought to be able to just put that one right in, and now it doesn't give us a division by 0 error, and so we have computed the limit.